Hello students. Now we discuss the chapter infinite series. So first we go through the definition. So what is a infinite series? So here we are considering some real numbers, that is u1, u2, u3, so on, un and so on. So these are the real numbers. So these are called the infinite sequence of real numbers. And when we write the sum of these, like u1 plus u2 plus u3 plus so on un plus up to infinity terms, then this is called an infinite series. And this infinite series usually we denote by the summation as summation n equal to 1 to infinity un, or simply we write as a summation un. So when we substitute n values here, like n equal to 1 2 3 so on, we get a infinite, the expansion of this we get. Okay, now the sum of its first n terms, like u1 u2 u3 so on un, so this is called the first n terms of the infinite series. U1 to un is called the sum of first n terms. Okay, so that we denoted by Sn. Okay, so this is the basic one. So therefore the sum of its first n terms is given by Sn equal to u1 u2 u3 so on un. Okay, now the types of the infinite series, the one is positive term series. So positive term series are what? An infinite series in which all the terms after some particular terms are positive, called a positive term series. Like the the terms having the positive sign, like 1 plus 2 plus 3 plus 4 and so on. So these are the examples of the positive term series. And other type of the series is alternating series. Alternating series is what? A series summation un is said to be an alternating series if the terms are alternatively positive and negative. The one term having positive sign, the other term having negative sign, the next term is positive, the next term having negative. Likewise, alternatively, the signs we have, those are called alternating series. Okay, so these are the types of the series. So now the main the definition of this chapter: convergence, divergence and oscillatory of a series. So now we go through what is a convergence and what is divergence and what is oscillatory. Suppose there is a infinite series summation un when n equal to 1 to infinity, so that we write the expansion form as u1 u2 u3 so on un up to infinity. Now we are going to define, so how when you say the infinite series is convergent. Okay, so to say that the infinite series is convergent, first we need to write the nth term of the nth term of the infinite series. So that is the first n terms is given by Sn equal to u1 u2 u3 so on un. So clearly Sn is a function of n. So when you write the nth term of the infinite series, so that nth term Sn must be a function of n, and we are going to check that value of Sn when n equal to infinity. We are going to put the value of n as infinity, then we are going to check that what is the value of Sn. Okay, suppose if Sn tends to a finite limit when we put n equal to infinity, then the series summation un is said to be convergent. That is, so this is the function of n, means this Sn is in terms of n. So when we substitute n equal to infinity in this function of n, if we get the finite quantity, then we say that the given infinite series is convergent. Okay, suppose when we substitute n equal to infinity in the function of n, suppose if you get the plus infinity or minus infinity, the value of Sn is plus infinity or minus infinity. When we substitute n equal to infinity, then the series is called divergent. Okay, then the third definition is oscillator. When we say the infinite series oscillatory, when in the Sn, when we substitute n equal to infinity, if we get more than one limit means we get more more than one. You may get the two values of Sn when we put n equal to infinity, two finite values or two infinite values. So this is here more than one limit as n tends to infinity, either finite or infinite. Okay, then the series summation un is said to be oscillatory. Okay, so these are the three important definition of the chapter. So now, before going to the problems, that is the given infinite series is either convergent or divergent, first we go through some basic results. Okay, the one important property of the infinite series is fundamental property. What is a fundamental property? If the summation un is what? This is the given infinite series is convergent, then the value of un when n equal to infinity is 0. That is limit un and when n tends to infinity is 0. Then we say that the given infinite series is convergent, but converse is not true. Means whenever this infinite series is convergent, it must the value of the value of this limit must be 0. But converse is not true. Means if you take any function of un, any function of n, then you put n equal to infinity, if the value becomes 0, it may not be convergent. It may not be convergent. But for any infinite series, if we say that it is a convergent, this limit must be 0. Okay, so this is called fundamental property. The other important result is harmonic series. So what is a harmonic series? So when we write the series summation vn, that is summation 1 divided by n raised to p, so this is called the harmonic series. You know that that's a basic concept. I'm going to expand this. When n equal to 0, when n equal to 1, 2, 3 and so on, when n equal to 1 we get 1, when n equal to 2 1 by 2 raised to p, when n equal to 3 1 divided by 3 raised to p, like that. This is the nth term 1 by n raised to p and up to infinity. So this is the harmonic series. Now for this harmonic series we have the conditions that, so we say that this series harmonic series is convergent when p is greater than 1. If p is greater than 1, for example 1 divided by n square, 1 by n square, so here p equal to 2, which is greater than 1. So 1 by n square we say that it is a convergent. Okay, suppose if p is less than or equal to 1, if it is like for example 1 divided by n, so p equal to 1. For p equal to 1 and less than 1, that harmonic series is divergent. Okay, so we need to remember these two conditions. That is when p is greater than 1, the harmonic series is convergent. When p is less than or equal to 1, the harmonic series is divergent. Okay, so these are the two important results in infinite series. Okay, so now we are going to discuss the one of the test in the sense we are, for the given infinite series we are going to check the nature, that is whether the given series is convergent or whether it is a divergent. So that is test for convergence for series of positive terms. Then what is this comparison test? So if summation un and vn be any two series of positive terms such that limit un divided by vn is a non-zero finite quantity, then summation vn and summation vn behave alike. that is summation un and summation vn, both will converge or both will diverge. So that means actually this summation un, this summation un is the given infinite series. Then from this un we find vn. In the next step I will tell how to find vn. So this un will be given in the problem. From that we are going to obtain vn. Then so this limit we are checking. How to check the limit? We take the un value, then this vn we are obtaining from vn un. Now this vn we are obtaining from un, then we take un by vn, limit n tends to infinity. So this limit we are going to evaluate. If the value of this limit is non-zero, finite quantity, if it is the value of this limit is a non-zero, then we say that both the summation un and summation vm behave alike, means the nature of both the series are same. If the one is convergent, the other is also convergent. If one is divergent, the other one is also divergent. Then checking this condition, we are going to say that whether the given summation un is convergent or divergent. How? See the note. In this test, the given series summation un is to be compared with the another series summation vn. Means when this condition is satisfied, that is this limit is non-zero, then we are going to compare the nature of this summation un with the summation vn. What is this summation vn now? Whose nature is to be known. So already we know the nature of this vn. So vn is in which form? Which is in the harmonic series form. So we are going to get the vn from the un which is in the form of 1 divided by n raised to p, which is convergent for p is greater than 1 and divergent for p less than or equal to 1. Okay, what we do, from the un you are getting the vn, there is some procedure to get the vn, then we are satisfying this condition, that is the value of this limit is non-zero. Then what we do, we take the nature of the summation vn. Suppose summation vn, that is the value of p is greater than 1, then we say that summation vn is convergent if p is greater than 1. If summation vn is convergent, definitely this summation un is also convergent, because by this test, if p is less than or equal to 1, then summation vn becomes divergent. When summation vn become divergent, summation un is also divergent, because both behave alike. Okay, so this is the way we apply the comparison test. And these are here is the working procedure. First, write the nth term of the given series. Okay, that is a, we are going to get the un. This test is usually applicable when the given series involves expressions of n in the numerator and also in the denominator, like n plus 1, 2n plus 1, n square plus 1, root n, n cube plus 4 means. So these are the types of function of n. Whenever in the given series, if we have the terms of n in these forms, then we apply the comparison test. Okay, this is the one point. Now here is the point how to choose the vn. The vn formula is given by 1 divided by n raised to p minus q, where p and q are highest highest powers of n in the denominator and numerator of the given series un. Okay, so in the example I will tell you what is that p and what is that q. So p is what? It is the highest power of n in the denominator. Q is the highest power of n in the numerator. From that we choose a vn. Okay, and this is the another the point. If the given series in the form of summation f of n minus g of n, or square root of f of n minus g of n, or square root of f of n minus square root of g of n, in such case we apply the rationalize method, so that we get numerator and denominator. So this rationalize method we apply to get denominator. Okay, because whenever we have such kind of terms, to get the denominator we apply the rationalize method. Okay, so here is one example for the comparison test. See, this is the given infinite series: 1 divided by 1 into 3 plus 2 divided by 3 into 5 plus 3 divided by 5 into 7, and so on. So here the first important point is write the nth term, that is a un we have to write. How to write the un, that is a nth term, what we call sn, right? How we write this? We have one term in the numerator, that is 1 2 3. So these are the terms in the numerator, and we have two terms, or we can say two factors in the denominator, that is 1 3 5 7, and so on. This is one kind of factors. The second kind of factors are 3 5 7, and so on. For these three we write nth term separately, like we take for the numerator 1 2 3. Okay, so 1 2 3 4. How to write the nth term? We have a that basic formula, a plus n minus 1 into d, where a is the first term of the series and d is the difference between the values of the given values. Okay, now a plus n minus 1 into d. A is 1, that's the first value of the series, plus n minus 1 into the difference between the terms are 1. So therefore the result is n. Okay, so this is the nth term for the numerator. For the denominator, take the first factors 1 3 5, 1 3 5 7. So first term a equal to 1, the difference is 2. So therefore a plus n minus 1 into d is given by 1 plus n minus 1 into d is 2. So the result is 2n minus 1. The second factors are 3 5 7, and so on. A equal to 3 first value, and the difference is 2. Okay, next we write the nth term of the second factor, a plus n minus 1 into d. Okay, so 3 plus n minus 1 into 2, the result is 2n plus 1. So therefore the nth term of the infinite series is given by the numerator is n, the first factor is 2n minus 1, the second factor is 2n plus 1. Yes. Now what we do after writing the nth term, we do one work, that is we take the highest power of n from the numerator and highest n from the denominator. See, we have only n, keeping this n from this bracket, n from this bracket we take as a common, n from this and n from this, we get n square here, this n and n square, so one n cancel here, so that n I wrote here, this n cancelled, 1 divided by this remaining n. Then when we took the n common, this is 2 minus 1 by n, we took n common, 2 plus 1 by n. Usually we write the given un in this form by taking highest power of n common in the numerator, also in the denominator. After writing in this form, we choose a vn. See how we are choosing vn. 1 divided by n raised to p minus q is the formula. 1 divided by n raised to, what is p? P is the highest power of n in the denominator. From these three terms, the highest power of n is n, that is 1 here. The power of n is 1, p equal to 1. Then highest power of n from the numerator, we do not have any n term, so n raised to 0, so q equal to 0. So therefore the value of vn is 1 by n. Okay. Now we apply the comparison test. We take un divided by vn as n tends to infinity. Okay, so this we write the simplified form as n divided by n into 2 minus 1 by n into 2 plus 1 by n. So again this n cancel, we put n equal to infinity. When n equal to infinity, so 1 divided by 2 minus 1 by infinity, 1 by infinity is 0, into 2 plus 1 by infinity, again it is also 0. So 1 divided by 2 into 2, that is 1 by 4, which is a non-zero finite quantity. We must get non-zero value. Okay, when we get the non-zero value, then by comparison test we say that both summation un and summation vn behave alike, means if both are converge or both are diverge. Then how we say that summation un is converge or diverge? Depending on the nature of summation vn. Summation vn is what? 1 by n. What is the value of p? P equal to 1. When p is 1, when p is 1, by harmonic series it is a divergent. Okay, so therefore we say that summation vn is divergent. When summation vn is divergent, summation un is also divergent, because both summation un and the summation vn behave alike. Okay, so this is the comparison test problem. Thank you.